National Electrical Code Article 300.3 C states conductors of different systems occupying the same enclosure shall be separated from each other by a barrier. National Electrical Code Article 300.22 It defines a barrier as a physical obstruction that prevents contact with or exposure to the objects it separates. National Electrical Code Article 334.15 states that electrical wiring systems shall not be installed in ducts, plenums, or other air handling spaces unless the wiring systems are listed as suitable for such use. National Electrical Code Article 480.1 It states that tubing for the transport of air shall be listed or approved for such use. Based on these code articles, it is not acceptable to run air supply tubing inside a wireway along with 480 volts AC, three-phase wires. The air tubing and the electrical wires must be separated by a barrier. The air tubing may contain moisture, and if it were to break, water could get on the wires and cause a short circuit. This could create a fire hazard. To comply with the code, one must either install the air supply tubing in a separate enclosure or use tubing that is listed for use with electrical wires. When installing electrical systems, safety and code compliance are paramount. The National Electrical Code, or NEC, provides guidelines to ensure installations are safe and reliable. A common question arises regarding the commingling of different systems within the same enclosure, specifically air supply tubing and electrical wiring. Let's examine the scenario, focusing on the relevant NEC articles and the implications for electrical safety. Consider the scenario where air supply tubing is run inside a wireway alongside 480 volts AC three-phase wires. A wireway is a metallic or non-metallic trough used to protect and route electrical conductors. The primary concern is that air tubing may contain moisture. If the tubing were to break or leak, the moisture could come into contact with the electrical conductors, potentially leading to a short circuit, equipment damage, or even a fire. The NEC addresses this situation directly. National Electrical Code Article 300.3 C pertains to conductors of different systems occupying the same enclosure. This section mandates that conductors of different systems must be separated from each other by a barrier. This requirement is in place to prevent accidental contact between different electrical systems, and in this case to protect electrical conductors from non-electrical systems such as air supply tubing. What constitutes a barrier? The NEC defines a barrier in Article 300.22 as a physical obstruction that prevents contact with or exposure to the objects it separates. In the context of air supply tubing and electrical wiring, the barrier should be sufficient to prevent any moisture or contact between the two systems. This could be achieved by using a physical divider within the wireway or by enclosing the air tubing in a separate conduit within the wireway. It's important to note that the barrier must be robust enough to withstand the environmental conditions of the installation, including temperature variations and potential mechanical stresses. Air handling spaces are also addressed by the NEC. National Electrical Code Article 334.15 stipulates that electrical wiring systems should not be installed in ducts, plenums, or other air handling spaces unless the wiring systems are specifically listed as suitable for such use. This provision is aimed at preventing the spread of fire and smoke through air handling systems. While a wireway is not typically considered an air handling space, the proximity of air supply tubing raises a similar concern. If the air tubing were to leak and come into contact with the electrical wiring, it could create a fire hazard that could be exacerbated by the presence of an air supply. National Electrical Code Article 480.1 further emphasizes the importance of using appropriate materials. This section requires that tubing for the transport of air must be listed or approved for such use. This means that the air tubing must be designed and tested to withstand the conditions of its intended application, including temperature, pressure, and exposure to chemicals or other substances. The use of listed or approved tubing helps to minimize the risk of leaks or failures that could compromise electrical safety. Now let's consider the implications of these code articles for the installation of air supply tubing and electrical wiring. Based on the NEC requirements, It is generally not acceptable to run air supply tubing inside a wireway along with 480 volts AC, three-phase wires without a proper barrier. The risk of moisture from the air tubing coming into contact with the electrical conductors is too great. To comply with the code, there are several possible solutions. Firstly, one could install the air supply tubing in a separate enclosure. This would physically isolate the air tubing from the electrical wiring, eliminating the risk of contact. The separate enclosure could be another wireway, a conduit, or any other suitable enclosure that provides adequate protection. Secondly, one could use tubing that is specifically listed for use with electrical wires. This type of tubing is designed to be resistant to moisture and other environmental factors, and it may be suitable for use in the same enclosure as electrical wiring. However, it's important to verify that the tubing is listed for the specific application and that it meets all applicable code requirements. Thirdly, one could install a barrier within the wireway to separate the air supply tubing from the electrical wiring. This barrier must be a physical obstruction that prevents contact between the two systems. It should be made of a non-conductive material and should be securely fastened in place. The barrier should also be designed to prevent moisture from migrating from the air tubing to the electrical wiring. When installing electrical systems, it's always best to consult with a qualified electrician or electrical engineer. These professionals can help to ensure that the installation meets all applicable code requirements and that it is safe and reliable. They can also provide guidance on the selection of appropriate materials and installation methods. Furthermore, it is important to stay up to date on the latest revisions to the National Electrical Code. The NEC is updated every 3 years, and it's essential to be aware of any changes that may affect electrical installations. Changes in the NEC can impact the way electrical systems are designed, installed, and maintained. Consider the specific requirements for wireways. Wireways must be supported in accordance with the NEC, typically at intervals not exceeding 5 feet. This support ensures that the wireway does not sag or become damaged, which could compromise the safety of the electrical wiring. Wireways must also be properly grounded to provide a path for fault current in the event of a short circuit. The grounding conductor must be sized in accordance with the NEC and must be securely connected to the wireway. In addition to the general requirements for electrical installations, there are also specific requirements for 480 volts AC three-phase systems. These systems are commonly used in industrial and commercial applications to power large equipment and machinery. The NEC contains detailed requirements for the installation of 480 volts AC systems, including conductor sizing, overcurrent protection, and grounding. When working with 480 volts AC systems, it's essential to exercise caution and to follow all applicable safety procedures. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and using insulated tools. It's also important to energize the circuit before working on it and to verify that the circuit is de-energized using a voltage tester. The use of appropriate labeling and signage is also important for electrical safety. Electrical panels and enclosures should be clearly labeled to indicate the voltage and amperage of the circuits they contain. Warning signs should be posted in areas where there is a risk of electrical shock or arc flash. These signs help to alert workers to potential hazards and to prevent accidents. Regular inspection and maintenance of electrical systems are also essential for ensuring safety and reliability. Electrical systems should be inspected periodically to identify any potential problems, such as loose connections, damaged insulation, or corroded components. Any problems that are identified should be promptly corrected to prevent them from escalating into more serious issues. Maintenance activities, such as tightening connections and cleaning components, can help to extend the life of electrical systems and to improve their performance. In conclusion, the commingling of air supply tubing and electrical wiring in a wireway raises significant safety concerns. The NEC provides clear guidelines on this issue, requiring that conductors of different systems be separated by a barrier. To comply with the code, one can either install the air supply tubing in a separate enclosure, use tubing that is specifically listed for use with electrical wires, or install a barrier within the wireway. By following these guidelines and consulting with qualified professionals, one can ensure that electrical installations are safe, reliable, and compliant with all applicable code requirements. It is imperative to consider the potential hazards associated with moisture and electrical systems. Moisture can significantly reduce the insulation resistance of electrical wiring, increasing the risk of short circuits and ground faults. In addition, moisture can corrode electrical components, leading to equipment failure and potential fire hazards. For these reasons, it's essential to take steps to prevent moisture from coming into contact with electrical wiring and equipment. This can be achieved by using moisture-resistant materials, installing drainage systems, and providing adequate ventilation. In areas where moisture is unavoidable, such as outdoor installations or wet locations, it's important to use equipment that is specifically designed for those conditions. This includes using waterproof enclosures, corrosion-resistant materials, and ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect small amounts of current leakage to ground and to quickly disconnect the circuit, preventing electrical shock. In addition to moisture, other environmental factors can also affect the safety and reliability of electrical systems. These factors include temperature, humidity, and exposure to chemicals or other substances. Extreme temperatures can cause insulation to break down, leading to short circuits and ground faults. High humidity can accelerate corrosion and increase the risk of electrical shock. Exposure to chemicals or other substances can damage electrical components and create fire hazards. To mitigate these risks, it's important to select equipment that is suitable for the specific environmental conditions of the installation. This includes using equipment that is rated for the appropriate temperature range, humidity level, and chemical exposure. It's also important to provide adequate ventilation to prevent the buildup of heat and moisture. In industrial and commercial settings, electrical systems are often subjected to heavy loads and frequent switching. These conditions can generate heat and stress on electrical components, leading to premature failure. To prevent these problems, it's important to use high-quality equipment that is designed for heavy-duty applications. This includes using conductors with adequate ampacity, overcurrent protection devices with appropriate interrupting ratings, and enclosures that can withstand the mechanical stresses of the environment. In addition to selecting appropriate equipment, it's also important to follow proper installation practices. This includes ensuring that conductors are properly sized and terminated, that connections are tight and secure, and that equipment is properly grounded. Proper installation practices help to minimize the risk of electrical faults and to ensure that the system operates safely and reliably. Regular training and education are also essential for electrical safety. Electrical workers should be trained in the proper procedures for installing, maintaining, and repairing electrical systems. They should also be educated on the potential hazards associated with electricity and on the importance of following safety precautions. Regular training and education help to ensure that electrical workers have the knowledge and skills necessary to perform their jobs safely and effectively. In summary, electrical safety is a complex and multifaceted issue that requires careful attention to detail. By following the guidelines of the National Electrical Code, selecting appropriate equipment, using proper installation practices, and providing regular training and education, one can minimize the risk of electrical hazards and ensure that electrical systems operate safely and reliably. Remember that electrical codes and standards are constantly evolving, so it's important to stay up to date on the latest revisions. Consulting with qualified professionals and seeking guidance from industry experts can also help to ensure that electrical installations are safe and compliant with all applicable requirements. Safety should always be the top priority when working with electricity. It's better to be safe than sorry. A thorough understanding of the NEC and adherence to established safety practices are essential for protecting lives and property. Furthermore, consider that the type of air being transported in the turbine also plays a role. Compressed air systems often contain oil and other contaminants that could exacerbate the effects of a leak. If the air is used for pneumatic controls, for example, even small amounts of moisture or oil could cause malfunctions or damage to sensitive equipment. In such cases, the need for separation becomes even more critical. The potential for condensation within the air tubing should also be taken into account. Changes in temperature can cause moisture to condense inside the tubing, increasing the risk of water accumulation and potential leaks. Insulating the tubing can help to minimize condensation, but it does not eliminate the risk entirely. Another factor to consider is the type of wireway being used. Some wireways are designed with features that help to prevent the ingress of moisture and other contaminants. These wireways may be more suitable for applications where air tubing is present, but they still do not eliminate the need for separation or other safety measures. The long-term effects of exposure to moisture and contaminants should also be considered. Even if a leak is small and does not immediately cause a problem, prolonged exposure to moisture can corrode electrical components and weaken insulation, leading to eventual failure. Therefore, it's important to take a proactive approach to prevent leaks and to address any signs of moisture or corrosion promptly. In addition to the NEC requirements, local codes and regulations may also apply. It's important to check with the local authorities to ensure that the installation complies with all applicable requirements. Local codes may have more stringent requirements than the NEC, or they may address specific issues that are not covered by the NEC. The role of qualified inspectors in ensuring electrical safety cannot be overstated. Qualified inspectors have the knowledge and experience to identify potential hazards and to ensure that electrical installations comply with all applicable codes and standards. They can also provide valuable guidance on how to improve electrical safety and to prevent accidents. Inspectors play a crucial role in protecting lives and property, and their expertise should be valued and respected. Continuous improvement is a key aspect of electrical safety. Electrical systems should be regularly evaluated and updated to ensure that they meet the latest safety standards and that they are functioning properly. This includes replacing outdated equipment, upgrading wiring, and implementing new safety measures. Continuous improvement helps to reduce the risk of electrical hazards and to ensure that electrical systems remain safe and reliable over time. In addition to technical considerations, human factors also play a significant role in electrical safety. Human error is a leading cause of electrical accidents, so it's important to address the human factors that contribute to these errors. This includes providing adequate training, promoting a culture of safety, and implementing procedures to prevent mistakes. By addressing the human factors that contribute to electrical accidents, one can significantly reduce the risk of injury and property damage. The importance of communication in electrical safety cannot be overemphasized. Electrical workers should communicate effectively with each other and with other personnel to ensure that everyone is aware of potential hazards and that everyone is following proper safety procedures. Clear and concise communication helps to prevent misunderstandings and to ensure that tasks are performed safely and efficiently. Finally, remember that electrical safety is everyone's responsibility. Everyone who works with electricity or who is exposed to electrical hazards should be aware of the risks and should take steps to protect themselves and others. By working together to promote electrical safety, one can create a safer and more productive work environment. Always err on the side of caution when dealing with electricity. If unsure about something, seek the advice of a qualified professional. The cost of safety is far less than the cost of an accident. Prioritize safety above all else, and never take shortcuts that could compromise the well-being of yourself or others. Review the installation periodically to ensure continued compliance and safety. This is especially important after any modifications or repairs have been made to the electrical or air systems. Keeping accurate records of all electrical work, including inspections, repairs, and modifications, is essential for maintaining a safe and reliable electrical system. These records can be used to track trends, identify potential problems, and to ensure that all work is performed by qualified personnel. Properly maintained documentation also assists in future troubleshooting and upgrades. The use of technology can also enhance electrical safety. For example, thermal imaging cameras can be used to detect hotspots in electrical equipment, which can indicate potential problems such as loose connections or overloaded circuits. Similarly, data logging equipment can be used to monitor voltage, current, and other electrical parameters over time, providing valuable insights into the performance of the electrical system. Technology-based safety measures can improve the effectiveness of inspections and maintenance activities and can help to prevent electrical accidents.